So let us now come to the question B of this tutorial 4, which is now relating to the entire water phase diagram to the first law of thermodynamics, which you have already learnt. And let us try to apply this knowledge what we have learned from the phase diagram to the first law, and where we do the energy and work balance and try to find out the phases at various locations in the phase changes or the property changes. So let us come to the problem, and question B says now, compute the changes in the thermal energy and enthalpy and expansion work done when 1 kg of saturated liquid water at T is equal to 100 degree centigrade evaporates isothermally to dry saturated steam. So one can understand from here that initially it was a saturated liquid and the final state it saturated steam or dry saturated steam. That means the entire process happens at the same pressure and the same temperature when 100% of liquid gets converted to 100% of dry saturated steam. So can you guess from here where does the state 1 and where does the state 2 lie? Alright, let us now come to the solution of this problem. So for understanding, we can take a cylinder and piston arrangement wherein we can have saturated liquid in the volume, and once the liquid gets evaporated to steam, we can get work done from this system. So we can take a cylinder piston arrangement to understand this problem. So our system could be a cylinder piston arrangement, consist of cylinder piston arrangement, and this dotted line shows my system, alright. Also we can draw the diagram on a PV process diagram on a PV plane. So this is P and V, and we can understand from the question that my initial state it as saturated liquid region, the final state is on saturated vapor region. So these are point 1 and point 2, and this process happens at constant pressure and constant temperature, and this P happens to be, we have been given temperature which is T is equal to 100 degree centigrade. Alright, that means we should refer to basically table 1. So what do we have to refer? We go to table 1, locate 100 degree centigrade and get the values at the F point and the G point, because the initial point lies on a saturated liquid curve and the final point lies on a saturated vapor curve. So we get the F values and the G values and we can solve the problems. So if I go to the steam table now and get the values at point 1, state 1 and state 2. This is state 1 and this is state 2. So can we get to the steam table? So this is table number 1 and 100 degree centigrade. So we know 100 degree centigrade is the phase change point, that means we have to be at 0.1 MPa, that is atmospheric pressure. And corresponding to this now we can get all the properties related to Vf Vg, Uf Ug, Hf Hg and Sf Sg. Please note down all these values, then we can come back to solution again. So the properties at state 1 and state 2 can be read from the steam table, and I will write down those values. So Vf is equal to 0.00104 meter cube per kg, and for state 2 Vg is equal to 1.67 meter cube per kg. Then I will get Uf is equal to 419.06 kilojoule per kg, and I will get Ug is equal to 2506 kilojoule per kg. The third property I am concerned about is enthalpy, which is Hf is equal to 419.17 and Hg is equal to 2675.6 kilojoule per kg. So, these are different properties that we read for state 1 and state 2 as shown in the diagram. Now, we understand that this process expansion, the process of expansion is a constant pressure process, alright. So, expansion work W expansion is equal to, because this is a constant pressure process, P is equal to V2 minus V1 into M, and V2 is nothing but Vg, V1 is nothing but Vf. If we write those values, the pressure is 0.1 MPa, which is 0.10142 into 10 to the power 6 per Newton per meter square into V2 minus V1, that is our Vg minus Vf here, 1.6718 minus 0.00104 meter cube per kg into 1 kg. This will give us expansion work which is equal to 169,448.13 joules, which is equal to 169.44 kilojoules. So, this is my expansion work. We have got different properties. This was one of the questions that was asked. The other question is, what are delta U and what is delta H? So, delta U is nothing but change in thermal energy, which we have just calculated. We have seen that m into Ug minus Uf, which is equal to, if I put these values of Ug and Uf here, I will get around 2086.94 kilojoule, which is nothing but actually Ufg, because this is per kg. Similarly, delta H is nothing but m into Hg minus Hf, which is nothing but m into Hfg, isn't it, and Hfg, which is equal to 2256.4. So, my answers therefore are, the expansion work is equal to 169.44 kilojoule, and the change in thermal energy and the change in enthalpy is given by this formulation, alright. So, this is the answer for this question. Let us come and write those answers, alright. So, change in enthalpy is 2256.4 kilojoule, change in thermal energy delta U, which is 2086.94 kilojoule, and work of expansion is 169.45 kilojoule, which is a positive work done by the system, alright. So, this is the first problem that we have seen, where we apply the water, basically water substance, use the steam table and apply to the first law of thermodynamics. Thank you.